So welcome you all. Good afternoon all my dear students. We'll be starting the paper discussion of the second mock test paper. Yeah. So yes, hope all of you have did your exam very well, and today we will be discussing all the questions that has come in the last mock test that you have did. Okay. So like we'll be discussing questions one by one. All of you just go through the question and get the answer and let me know the answers in the chat box, and if you are facing difficulty I will be solving that in the class. Okay, so whatever the doubt you are having, that also you can ask and you can clear it right now. Okay, so we'll be moving to the first question. That is very easy question. I hope all of you did this answer correctly. Is it? Yes. So what is the answer? What is the answer for this one? Very easy question. The best method, yeah, option C. Very good. Why option C is the correct one? Why option C is the correct one, and why not the other options? We know that. Yes, very good. That is, here we can see conversion of alcohol, that is ROH plus SOCl2. We will be getting what? RCl, alkyl chloride we got, and along with the alkyl chloride, what are the other things we are getting? We are getting SO2 gas and HCl gas, and these two gases will be evaporating out, which will make the product more, will be making the yield of the product more. Okay, so yeah, option C. That's why option C is the one. Option A also we can prepare RCl from option A also, that is from PCl5, but the product that we are getting is a liquid which is not making the RCl product yield more. Okay, that's why we are not considering this as the best method. Same thing, using dry HCl also in presence of anhydrous ZnCl2, which is Lucas reagent. Using that also we can do it, but yeah, the product that is obtaining will be very less. Okay, so that is why the best method is SOCl2 in presence of pyridine, and this method is also called as what? Darson's process. Yes, very good. This is also called as Darson's process. It's very easy question. Shall I move to the next question? I want to cover up all the questions so that we will be moving bit faster. Yes. Second question. A compound formed by heating benzene sulfonic acid with a molten NaOH followed by acidification. It's a very easy question. Very easy and a basic method of the preparation of phenol, right? Benzene sulfonic acid I am taking, SO3H, and what I am doing? I am heating molten NaOH in presence of acid. What is the product we are getting? Yeah, the product we are getting is phenol. Okay, it's a basic industrial method of preparation of phenol. Yes, option D is the correct one. Shall I move? Yes. Okay, moving to the next question. Yes, how many of you got the correct answer for this question? How many of you got the correct answer for this question? What is the answer? Actually, this is one of the good questions that I have seen in this mock test. What is the correct answer? Option B is the correct answer. Okay, yeah. Anyone else have any other different options? Anyone else having a different option you got? Option B, apart from that? Okay, how we can solve this question? You will be thinking it is a very simple question, but actually not. Okay, here we can read the question clearly. The vapor pressure of a pure benzene and toluene at a particular temperature are 100 millimolar, 100 mm and 50 mm respectively. Okay, first of all we can take out the data that is given in the question, that is P naught of benzene. Vapor pressure of benzene I am writing it as P naught of B, which is given as 100 mm of Hg, and then for toluene, P naught of toluene, that I am writing it as P naught of T, it is equal to 50 mm. Okay, then the mole fraction of benzene in vapor phase. The question is the mole fraction of benzene in vapor phase. How we can find out that one? Vapor pressure of benzene vapor phase in contact with the equimolar solution of benzene and toluene. They have mentioned that is there is an equimolar solution of benzene and toluene. If there is equimolar solution of benzene and toluene, what will be the number of moles of benzene and toluene? If I am making the number of moles of benzene as 1, then number of moles of toluene also will be 1. Okay, that's I can take it. Okay, if I got these two things, I can find out the mole fraction of benzene, right? I can find out the mole fraction of benzene. How I can find out the mole fraction of benzene? 1 by 1 plus 1, it is equal to 1 by 2. At the same time, the mole fraction of toluene, what it is? 1 by 1 plus 1, it is equal to 1 by 2. I got these all the data that I have got directly from the question. Got it? Now what is the question? Is the question is asking about this mole fraction? Is the question is asking about that mole fraction in which we already got the answer? Is it? Is it? Tell me guys. Yes or no? No, right? Then what is actually asking in the question? Question is asking the mole fraction of benzene in its vapor phase. Okay, for that I will be just giving you an idea about what actually it is asking. Consider a beaker in which I have a mixture of solution of benzene and solution of benzene and toluene. Okay, suppose it is having benzene and toluene. Okay, and the mole fraction of benzene, it is represented as chi b, and the mole fraction of toluene is represented as chi t. Okay, this is in liquid phase. Now we are not at all bothered about this liquid phase. What we want to do, we need to find out the vapor pressure of benzene and toluene in vapor phase. That is, after some days what we can see, the benzene will be vaporizing and will be there in the top of the benzene liquid. At the same time, toluene also will be vaporizing, right? Toluene also will be vaporizing and it will be there on the top of the liquid. Okay. Now look at here. For the question is asking about the mole fraction of benzene and toluene in this vapor phase only. That is what the question. For that, you should be knowing the partial pressure of benzene. Let's imagine that partial pressure of benzene is Pb and partial pressure of toluene is Pt. Okay, and what we have to find out? We have to find out the mole fraction of benzene in its vapor phase. That I will be representing it by using Yb, and mole fraction of toluene in its vapor phase, I am representing it as Yt. Yes, Chris, are you saying something? Any doubt? Okay. Yes. Now what we have to find out? The question is all about calculation of Yb and Yt. How we can calculate Yb and Yt? For that, we can't use Raoult's law. We can't use Raoult's law for that, because Raoult's law we can use if there is a mixture of two liquids, or if the solution is formed by the mixture of two liquid. But here we have to find out the mole fraction of two vapors. For that, how I can use? We can use Dalton's law of partial pressure. Yes, very good. We can use Dalton's law. According to the Dalton's law of partial pressure, the partial pressure of a liquid, the partial pressure of a substance in its vapor phase, example it is Pb, which is equal to
total pressure.
Yeah, total pressure into mole fraction of B into P total. This is according to Dalton's law of partial pressure. According to Dalton's law of partial pressure of a component in a mixture, it is equal to mole fraction of that component into total pressure. Okay, and what about Pt? Pt is the partial pressure of toluene, which is equal to mole fraction of toluene into P total. From this we can find out Yb, Ya and Yb. What is Yb? Yb will be equal to Pb divided by P total, and Yt is equal to Pt divided by P total. Now what do you have to find out? Now what are the things that you should calculate or find out from here? You should find out Pb and P total. Pb and P total you have to find out. How you can find out Pb and P total? Students, how you can find out Pb and P total? There you can use Raoult's law. Yes, very good. According to Raoult's law, Pb is equal to P naught B into chi B. Yeah, what is P naught B? P naught B is given in the question 100. and into chi b, mole fraction of benzene, it is equal to 1 by 2. Yeah, what is the answer we are getting here? We are getting 50. Now what about PA? PA is equal to P naught, sorry, not PA, it is PT. PT is equal to P naught of T into mole fraction of T. What is P naught of T? P naught of T is 50 into mole fraction, it is 1 by 2. I got it as 25. Yes, I got PB and PT. Now how I can find out P total? Total pressure. How I can find out P total or total pressure? P total is equal to PB, yeah, PB plus PT. Partial pressure of benzene plus partial pressure of toluene. PB. What it is? PB is equal to PT is equal to 25 plus 15, which is equal to 75. Yeah, exactly. Yes. Now everything we got. Now what we have to find out? Question is asking about mole fraction of benzene. Mole fraction of benzene, that is YB. Mole fraction of benzene is vapor phase. PB divided by P total. And PB already we have calculated, it is 50 divided by P total, that is 75. The answer will be coming 5 by 7. Yeah. What is 5 by 7 value? Yes. What is the value? What is the answer? Yes. What is the answer, guys? 0.67 is the answer coming, right? Yes. Have you understood this question? It's a little bit lengthier question, but all the concept we know already. Yes. Is it clear, everyone? Everyone got this question? It's a very important, very good question. I can say it's a very good question. Okay. Yes. Just to have an understanding about mole fraction in its vapor phase using this diagram. Okay. This is the, we are only talking about mole fraction of benzene and toluene in its vapor phase. And in that vapor phase, it is having mole fraction as well as the partial pressure. Partial pressure we will be finding out it by using the Raoult's law. Okay. So I can move, right? I can move to the next question. Are you all clear with this question? Shall I move? Yes. Okay. Yes. Another question. An energy of an electron in its ground state for He plus ion is minus x joule. Then that for an electron in N is equal to state for Be 3 plus ion in joule is. What is this answer? I think the same question was asked in the last mock test, right? Are you remembering? The same question was asked in the last mock test. You got the correct answer for this one, or still you made mistake? Hey guys, tell me. Last mock test we got the same question, right? What is the answer? What is the answer? Energy of an electron in its ground state, N is equal to 1. For helium it is minus joule. And yeah, for energy only we have to find out En is equal to, yeah, what's the answer? What's the answer? Anyone is saying? Minus 13.6 into n square by n square, okay, z square by n square, right? This is the energy equation. Yes or no? Yes or no?
Yes, sir.
You want to solve this question, the same question we have did in the last exam. Same question we have did in the last exam, I guess. Okay. For Illy, okay. For He plus what it is? Minus 13.6 into Z value is 2. So 4 divided by N value is 1. And for beryllium 3 plus what it is? Minus 13.6 into N is Z value of beryllium, it is 4. That is no, beryllium it is 3, right? Okay. No, 3, 4. So it will be 16. And divided by what is N value? N value it is 2 square, that is 4. So what is the answer we are getting? We are getting the energy of He plus is equal to energy of Be 3 plus. He plus in which N value is equal to 2 square, that is 4. 2 square by 4 that is 16. 16 into 3 plus what it is? Minus 13.6 into N value is 1. And for beryllium it is 3, right? So it will be 16. And divided by what is N value? N value it is 2 square, that is 4. So what is the answer we are getting? We are getting the energy of He plus is equal to energy of Be 3 plus. He plus in which N value is equal to n value is equal to 1, and for beryllium where n value is equal to 2, which is equal to, what is the answer? Minus 13.6 into 4. That's going to be the answer, which means both are same. If that value is minus joule, then for beryllium also it is minus x. Minus x joule means for beryllium also it is minus x. I think it's a very easy question, you can do it by, yeah, we can move to the next question I guess. Same question asked in the last mock test. I am moving. Shall I? Yes. Yeah, what is the answer for this question? I am not going to solve all these simple questions. You can find out the answer. Boiling point of butanol is higher than that of butane. Is it correct? Is it correct or wrong? Aldehyde. Boiling point of aldehyde is greater than that of butane. Is it correct? Yes. Very good, Surabhi. Option A. Yeah, that is correct. What is the reason? What is the reason? Reason everyone know. What is the reason? Aldehyde, we know that there is a dipole-dipole interaction. Dipole-dipole, CO. There is CO is a dipole, and there is a dipole-dipole interaction. Due to that dipole-dipole interaction, the boiling point will be higher. And in the case of alkane or butane, there is only van der Waals, weak van der Waals force of attraction. Because of that, what? The boiling point will be lesser. Okay, I am moving to the next question. Option, both assertion and reason are correct, and reason is also the correct explanation. Yes, option A. Next question. Shall I move? Yes. Which complex of CO2 plus will have the weakest crystal field splitting? Very easy question. Weakest crystal field splitting. What is the answer? Option A. Yeah, there is no need of thinking much. Weakest crystal field splitting will be happening from weak field ligand. Among all these, we can say that Cl, chlorine, is only the weak field ligand. So that is the correct one. Yes. Moving to the next question. The indicator used in the titration of acetic acid and sodium hydroxide for for the quantitative estimation is, what's the answer? Another easy question. What's the answer? A, B, C, D. Which indicator we will be using? I hope all of you know that which indicator we can use for a particular titration. If it is for a weak acid plus strong base titration, which indicator we are using? Phenolphthalein indicator we will be using, because it will be showing color change in the pH range of 8.1 to I think around 10.1 or 2. Phenolphthalein will be showing a color change in the pH range of 8.1 to 10.2, and here we are titrating weak acid versus strong base. The overall solution will be, at the time of endpoint, the solution will be slightly basic, and at that point when the solution become basic, or when the pH will be in the range of 8.1 to 10.2, the phenolphthalein will be showing a pink color. Okay, now what about for other, if it is for a weak base versus strong acid, what is indicator we will be using? Anybody have any idea? If they have asked about weak acid plus strong base, definitely in the next exam they can ask about weak base plus strong acid. Anybody have any idea which indicator we will be using here? Very good, methyl orange. Yes, methyl orange. And methyl orange will be showing color change in the pH range of 3.1 to 4 point something. Let me check it. Yeah, 4.4. 3.1 to 4.4. Okay, now what about for strong acid plus strong base? For strong acid plus strong base, what indicator we will be using? Strong acid plus strong base. Anybody have any idea? Bromethymol blue. Bromethymol blue will be showing pH, showing color change of pH from 6.6 to 7.6. Okay, so these are the other points that you have to note down along with the answer for this question. Okay, because question can ask from any of these things, and pH range also just note it down. Yes, I think it is clear to everyone. We can move into the next part. Shall I?
For a mixture of methyl orange and
for a mixture of, sorry,
methyl orange and methyl red.
Methyl orange and methyl red. both will be working with a weak base plus strong acid, and methyl red also will be having a pH range almost same, not exactly this one, I am not remembering, I think the same only, like around 3.5 to 5 point something only. It is also an acidic indicator. Methyl orange or methyl red, both will work. Yes. Yes. Sir, for weak acid and weak base, what we will use? For weak acid and weak base also the same thing, we can use bromthiamine blue. For strong acid and strong base also, like solution will be always almost in neutral, and for weak acid and weak base also same thing, only solution will be in the end point will be a neutral solution. So the pH range of the indicator which is having a neutral range, that is here you can see there is a pH range of neutral, right? So that can be used for strong acid plus weak base or weak acid plus weak base. Normally we won't do the titration of strong acid plus strong base or weak acid plus weak base. These two are the titration we are normally will be using. Okay, if it is weak acid and weak base, the same bromthiamine blue. Any indicator which is showing a pH range, which is showing a color change in the pH range of neutral, that can be used. Got it, Surabhi? Yes. Okay, we'll be moving to the next question. Acetanilide is less basic than aniline. Yeah. Acetylation of aniline results in a decrease of electron density on nitrogen. Tell me guys, what is the answer? Option A, B, C, D. Who is going to give the answer? A, B, C, D. What is the answer? Option A. Option A. Are you sure option A is correct? Okay, we can see it. Anybody have any other opinion? We can see it, no problem. Okay, first of all, just know the structure of acetanilide. What is the structure of acetanilide? Yeah. Okay. NH, double bond O, CH3. Okay, look at the structure of acetanilide and look at the structure of aniline. NH2. Okay, here you can see the acetanilide, the lone pair in nitrogen will be involves in the conjugation with the benzene ring, as well as it is involved in the conjugation with the carbonyl carbon also. That is, we can see there is a cross conjugation. You can see, because of the cross conjugation, this lone pair won't be available. This will be involved in both the conjugation. Lone pair won't be easily available for donation. If the lone pair is not easily available for the donation, then it is less acidic or less basic or more basic. Basic is all about how much easily a lone pair can be donated, and here you can see the lone pair of nitrogen is involved in the cross conjugation, in which it won't be available for donation. Okay, which means this is less basic. Now what about for this one, NH2? Here NH2, it is involves only in the extended conjugation. There is only one particular conjugation. Because of that, comparing to the acetanilide, NH2 lone pair is little more available for donation. So comparing to these, the more basic is aniline. So assertion is correct. Okay. Yeah. Now what is the reason? Acetylation of aniline results in a decrease of electron density of nitrogen. Is that correct or wrong? After the acetylation of aniline, what we are getting? We are getting acetanilide. And when I am comparing the electron density of nitrogen in aniline and acetanilide, you can see that electron density of aniline decreases, right? Less electron density. Because this lone pair of electrons in the nitrogen is involving in conjugation on both the sides. So because of that, after acetylation of aniline, nitrogen lone pair is not available because the electron density has decreased, because that is involved in both the conjugation. Because of that, we can say acetanilide is less basic than aniline. You understood this one? So I can say both the reason and assertion both are correct, and both is a correct explanation. Because lone pair on nitrogen is not available, because the electron density of lone pair on nitrogen decreases after acetylation. Got it, everyone? Is it correct? Okay, shall I move? Shall I move, guys? Yes. Okay. What about this question? In a compound, carbon, hydrogen and nitrogen are present in 9:3, 1:3.5 by weight. Molecular weight of the compound is 108. Molecular formula of the compound is, what is the molecular formula of compound? This is, we have discussed in the mole concept chapter. Yeah. How we can find out? If you are given with the mass ratio, if you are given with the mass, how we can find out the empirical formula? Molecular, yeah. First of all, find out the empirical formula. How we can find out empirical formula? Empirical formula, first of all, find out the molar ratio. Molar ratio of carbon, that is mass ratio, that is 9 divided by the mass of carbon, that is 12, and molar ratio of hydrogen, the ratio is, weight ratio is 1 divided by 1, it is equal to 1, and for carbon, hydrogen, then nitrogen it is 3.5 divided by what? 3.5 divided by, yeah, nitrogen it is 14. Okay, now what is the answer you are getting all these? Here is 0.75, here it is 0.25. Now what is the next step? Next step is simple molar, yeah, simple molar ratio. How we can find out simple molar ratio? Dividing each molar ratio by the lowest molar ratio among all these. So for carbon it is 0.75 divided by 0.25, for hydrogen it is 1 by 0.25, and for nitrogen it is 0.25 divided by 0.25. What is the answer you are getting? Here it is 3, here it is 4, and here it is 1. 3, 4 and 1 is the answer you are getting, and from that I got the, and this is in the whole number ratio also. So I got the empirical formula is, what is the empirical formula? C3H4 and O1. I got the empirical formula. Now how we can find out molecular formula from empirical formula? That equation also we have discussed. What is that equation? Empirical formula is equal to N into, molecular formula is equal to N into empirical formula, right? And what about this N? N is equal to molar mass divided by empirical mass. Molar mass divided by empirical mass. Molar mass divided by empirical mass. What is the molar mass? 108 divided by empirical formula mass. What is the empirical formula mass? What is the empirical formula mass? It is how many carbon? 3 carbon. 12 into 3 plus 4 into 1 plus 1 into 16. What is the empirical formula mass you got? It is coming 54. It is coming 54. So on doing this, you will be getting the value of N as 2. If you got the value of N as 2, so molecular formula is equal to 2 into empirical formula C3H4O1. What it is? C6H8O2. This is the answer. Is it clear? Is it? Is it clear?
N2, not
Sorry? Sorry, it's not oxygen, right? Yeah, sorry, it is N1. Okay, everything is N, right? N1. N, okay, so here it is plus 1 into 14 is equal to 54. Yes. N2, yes. C3H8N2, yeah, so the C6H8N2, so the correct answer is C. Got it, everyone? Yes. Is it clear to everyone? Shall I move to the next question? Everyone? Yes. Now the next question. Benzaldehyde is obtained from Rosenmund's reduction reaction. Rosenmund's reduction reaction. What is Rosenmund's reduction reaction? Yeah, option B is the correct one. It's a very simple question. Rosenmund's reduction reaction. How we can find out Rosenmund's reduction reaction? It is RCOCl. That is from acid chloride on treating with the H2 bar PD, BA, yeah, PD or PT, or in presence of BaSO4. BaSO4 is acting as a poison, and we will be getting R C double bond OH. Yes, we will be getting aldehyde. So among these you can see that okay, there is only acid chloride obtained, and you can see it is option B. And remember that BaSO4, it is a poison. What it will be doing is it will be preventing the further reduction of aldehyde to alcohol. Okay. Shall I move to the next question? Yes. Next one, identify the correct statement for a ring system to exhibit aromaticity. Aromaticity condition everyone know, right? It's a basic in the general organic chemistry. Yeah, what is the condition? It must not be planar. Is it correct? It's not wrong. It should be planar, cyclic, conjugated, and follows 4n plus 2 pi electron. This is the basic condition for a compound to show aromaticity. Correct statement is asking, it must not be planar. Yes, it is a wrong one. It should be planar. It must possess 4n plus 2 pi electron. Yes, that is correct one. It must be planar. It must possess 4n pi electron. No, 4n pi electron will be for anti-aromatic compound. It must possess, yeah, no. So correct answer is, okay, where are the options? Okay, option 2 and 3. Option 2 and 3. Yes, option D is the correct one. Shall I move to the next question? Okay. Just give me a minute. Okay, we have discussed a question now. Just we can go into that. What was that question? Okay, this question. Okay, I just got a doubt in this one. Acetylide is less basic than aniline. Okay, that is correct. Acetylation of aniline results in decrease in electron density on nitrogen. Okay, that's actually wrong one. That's actually wrong one, because we know that acid is involving in the resonance. There is no decrease in the electron density, because in the case of resonance, what is happening? Electron density will be same everywhere. Electron density will be same everywhere. How the electron density of nitrogen here, the same will be the electron density of nitrogen here, because it is involving in the resonance. We know that due to resonance, the bond length, bond strength, everything will be same, right? Because of the same electron density. So I think that is a wrong one. Okay, this is wrong one. Both assertion and reason are correct, but the reason is not the correct explanation. Acetylation of aniline results in decrease in electron density of nitrogen. Okay, think yeah, the statement or something is wrong somewhere. The reason is not the correct explanation. Yeah, due to the decrease in electron density, we can say that it is less basic. Okay, I have a doubt in this question. Okay, I will just check this question and will be letting you know in the next class. Okay, just hold this question. I will be just checking it once and I will be letting you know next class. Okay. Okay, now we'll be moving to the next question. I think the same question we did in the class, I guess. in the thermodynamics. Choose the reaction with a negative delta S value. Choose the reaction with a negative delta S value. Which one will be having lesser delta S value? Wherever the reaction it is going with decreasing randomness or decrease in movement, there we can see the entropy will be decreasing. Tell me the first option. NaHCO3, salt is converting into gas. Salt is converting into gas. If salt is converting into gas, what about the delta S? Positive or negative? Positive or negative? Tell me, guys. It is positive only. What about option B? Here 1 mole of Cl2 is converting into 2 mole of Cl. 1 mole is converting into 2, which means delta S is, that is randomness or movement is increasing. Delta S is positive. Now what about option C? Here all are in gaseous phase. All are in gaseous phase, and you can see 2 plus 1. 3 mole of gas is converting into 2 mole of gas, which means the number of moles, everything has been decreasing. As the number of mole decreases, delta S also will decrease. It is negative. So that is going to be our answer. Okay. Hope you got the answer. Is it, students? Is it correct? Is it what you got? Last one we can see. Here salt is converting into gas. Here KClO3 salt, it is converting into gas, you can see. So delta S is positive. Yes. I think this question is very easy, and the same question we did while solving the PYQs in the thermodynamics last class. Shall I move, students? Okay. Are you having a doubt in this? Very easy question now. Yeah, another question. How many of you got the correct answer for this question? Limiting molar conductivity of HCl, CH3COONA and NaCl are respectively 425, 90 and 125 MHO, centimeter square mole, milliohm, mole inverse at 25 degrees Celsius. Okay. Molar conductivity of 0.1 molar CH3COA solution is 7.8 milliohm centimeter square mole inverse one. It should be mole inverse at the same temperature. Then degree of dissociation. Here degree of dissociation or alpha is asking. How we can find out degree of dissociation or alpha? What is equation? This is one of the application of Kohlrausch's law. Applications of Kohlrausch's law. In the application of Kohlrausch, we have find out that alpha value we can find out by taking the ratio of molar conductivity and limiting molar conductivity. Yes, lambda m divided by lambda m naught. And what is the lambda m value given in the question? Molar conductivity of 0.1 molar CH3COH is 7.8 divided by lambda m naught. Lambda m naught is not given, but the details needed to find out lambda m naught is given in the question. Yes. How we can find out lambda m naught? Lambda m naught of CH3COOH is equal to lambda m naught of CH3COO minus plus lambda m naught of H plus. This is according to Kohlrausch's law. According to Kohlrausch's law, this is how we can find out limiting molar conductivity of a weak electrolyte. Okay. Now how we can find out these values? For that, the details that is given in the question is limiting molar conductivity of HCl is given and CH3COONA is also given. I will be adding that because CH3COO is there in the CH3COONA. So lambda m of CH3COONA plus lambda m naught of HCl. Okay, from here what I will be getting? I will be getting CH3COO minus and I will be getting H plus. But I don't want Na and Cl. To remove that one, I will be minusing that one, minus lambda m naught of NaCl. Now on solving this, what you will be getting? 90 plus 425 minus 125. What is the answer you got here? Lambda m naught. Lambda m naught value, what is the answer? Yes, 390 MHO centimeter square mole inverse. Yes. Now what you have to do, just substitute that over here. Just substitute that over here. That is 7.8 divided by 390. What's the answer? What's the final answer you are getting? 1 by 15 is equal to 0.02. Yes. Is it the answer? Is this the answer everyone got? Students, is it clear? Anybody have any doubt? Yes, option B is the correct one. Yes. Shall I move? Yes. Okay. In secondary structure of DNA, adenine forms hydrogen bonds with the guanine, whereas cysteine forms hydrogen bond with the thymine. Is it correct? RNA molecules are of three types: mRNA, rRNA and tRNA, and they all perform different function. What's the answer? What's the answer for this one? In secondary structure of DNA, in DNA, adenine forms hydrogen bond with the guanine. Is it correct? Biology question?
Yes, sir.
Yeah, all our biology students, right? Adenine will be binding it with thymine and guanine with the cytosine, right? Yes. So I think this is the wrong one. Yes. What about option statement second is correct, one is incorrect. Yes. RNA molecule are three types: mRNA, rRNA and tRNA. They all perform different function. Is it correct? Yes, that is correct. I think mRNA is messenger RNA. Messenger RNA will be, I think it is having a connection with the nucleus of DNA and the ribosome, right? Messaging. Yes. And rRNA will be structurally helping with the ribosome, and tRNA it is acting as an adapter between amino acid and the ribosome, right? So they all have the different function, and as you all are biology students, I hope you know the function of everything. Yes. Shall I move? Shall I move to the next question? Yes. IUP is the name of the following compound. Yeah, I think it's an easy question. You all got the correct one. What's the answer? N-phenyl ethanamide. N-phenyl ethanamide. What is IUPAC? N-phenyl ethanamide. That is, this is the 1, 2. This is our main chain 1, 2, and this is nitrogen. N-phenyl, then 2 carbon is there in the main group, and this is an amide group, NHC double bond O. So ethanamide. Yeah, nomenclature part. Moving to the next question. Same question we did in the class, I guess. What is the answer? Which of the following graphs represent exothermic reaction? For exothermic reaction, what I said? The
Option A.
Option A. Energy of product will be lower. Energy of product will be lower than energy of reactant. That's why exothermic reactions are more stable comparing to endothermic reaction. Moving to the next question. The correct statement from the following are: TL3 plus is a powerful oxidizing agent. Al3 plus does not get reduced easily. Both Al3 plus and TL3 plus are very stable in solution. Yeah, we can go to the options one by one. What is this concept? This concept is inert pair effect. According to inert pair effect, okay, the stability of higher oxidation state decreases as we move down in a group. As we move down in a group, like for the p block elements only, like carbon family, nitrogen family and boron family, decreases as we move down in a group due to the reluctance of s electrons to take part in reluctance of s orbital electrons to take part in bonding. Okay, what does it mean? I am taking the example of the boron family: boron, aluminium, gallium, indium and thallium. Normally, what is the electronic configuration, outer electronic configuration boron? It is ns2np1. ns2np1. Okay, because of ns2np1, it should be having a it should be having plus 3 oxidation state. It should have plus 3 oxidation state, but this plus 3 oxidation state stability will be decreasing as we goes down. As we goes down, the plus 1 oxidation state only will be stable. The plus 1 oxidation state only will be stable. Why? As we goes down, the s orbital electron won't be taking part in the reaction because s orbital will be more tightly holded to the nucleus due to the shielding effect of d and f block elements. D particularly for d block element. In thallium you can see there will be a d block element. Due to d block element, s orbital electrons will be more closer to the nucleus. S orbital electrons will be more closer to the nucleus. Okay, because of that we will be getting only plus 1 oxidation state as a stable one. Okay, if plus 1 is a stable one, will Al3 plus exist in plus 3? If plus 1 is a stable one, then will the Tl3 plus will be existing in plus 3 oxidation state? Is it? No. What it will be doing? If Tl which is in plus 3, it want to convert to Tl plus 1. How it will be converting to Tl plus 1? By reduction. If it is undergoing reduction, then it is acting as oxidizing agent. So Tl plus 3, I can say it is a powerful oxidizing agent. Going down, stability of higher oxidation state will be decreasing. Now Al3 plus does not reduce easily. Is it correct? Al3 plus, aluminium plus 3. Is it correct? Aluminium we can see it is in the top. As it is in the top, higher oxidation state will be stable, which means plus 3 oxidation state is stable for aluminium, and as it is stable it won't either undergoes reduction or oxidation, so it is correct one. Okay, now the question, Al plus 3 and Tl plus 3 are very stable in solution. Is it correct? Al plus 3 is stable but Tl plus 3 is not stable, so this is wrong one. Now my question is, Tl plus 1 is more stable than Tl plus 3. Is it correct? Thallium in plus 1 oxidation state is more stable comparing to thallium in plus 3 oxidation state. Is it correct? Yes or no? Of course, just now only we discussed no. For thallium, as it is in the bottom, lower oxidation state is stable, which means plus 1 oxidation state is stable for thallium. So this is correct. Al plus 3 and Tl plus 1 are highly stable. Yes, that is a correct statement. For aluminium, as it is in the top, plus 3 oxidation state is stable, and for thallium, as it is in the bottom, due to inert pair effect, plus 1 oxidation state is only stable. Okay, so what is the correct one? A, B, D, E. A, B, D, E. Option A is the correct one. Are you all understood the inert pair effect? This is the part that I missed in the periodic properties of elements because of the time limitation. Yeah, I hope I have covered that one here. What is inert pair effect is, as we goes down, stability of higher oxidation state decreases because of the less or poor shielding of d block elements, or sorry, d orbital. Due to the less shielding of d orbitals, s orbital won't be taking part in bonding. It will be tightly holded to the nucleus. Yes. Shall I move to the next question? Is it clear, everyone? Guys, are you there? Shall I move to the next question? Okay. Correct decreasing order for metallic character. We know that metallic character, it will be on going from top to bottom, metallic character will increases. Going from left to right, metallic character will decreases. Now you can see sodium, magnesium, beryllium, silicon, phosphorus. Going from left to right, metallic character will decreases. So that's the correct option. I don't think there is much explanation required for it. Yes, moving to the next question. Transition elements form colored ion due to what is the reason? What is the reason why transition element can form colored? Yeah, the reason we all know that is due to DD transition. There are transition element which is showing colored even though there is no d orbitals. What is the reason? Charge transfer spectra. Charge transfer spectra. due to charge transfer spectra, there are like KMnO4, K2Cr2O7. They don't have no d electrons, but they are colored due to LMCT, that is ligand to metal charge transfer. LMCT is ligand to metal charge transfer spectra. Okay, just note down this point also. Shall I move to the next question? Students, is it clear? Okay, moving to the next question. Which of the following salt shows maximum covalent character? I hope all of you have got correct answer for this question. Maximum covalent character. What is our principle behind it? Fajan's rule, right? Fajan's rule. According to Fajan's rule, covalent character is directly proportional to what? Polarizing power of cation and polarizability of anion. And polarizing power of cation, it is directly proportional to charge, inversely proportional to size. Polarizability of anion is directly proportional to charge and also directly proportional to the size. Okay, this is what according to the Fajan's rule. What is the answer? Here you can see we can't compare the covalent character based on the polarizability of anion because all the anions are same here. Then how we can compare? By using the polarizing power of cation. Polarizing power of cation, if you observe, directly proportional to charge and inversely proportional to size. So check among these which is having highest charge and smallest size. Highest charge and smallest size. 2 plus, 3 plus. Among these you can see Al3 plus and La lanthanum, La3 plus. Both are having highest charge. Now among these which is having less size, that will be more covalent. We all know that aluminum, which is in the top of the periodic table, it is having less size, so it is having maximum covalent character. Smallest size is for AlCl3, so because of that AlCl3 will be having highest covalent character. Next comes LaCl3 and then Mg2 plus, then CsCl. Okay, if you got a confusion between charge and size, the dominating one is charge. The one which is having higher charge will be having the highest covalent character. Yes, is it clear everyone? Already we discussed it in the chemical bonding chapter, so I hope you guys are not feeling any difficulty in this question. Shall I move? Shall I move, student? Are you guys are there? Yes. I need some thumbs up in between the class, then only I will get some motivation to move. Okay. Next question. Yeah, another question. I hope all of you have did this question correctly. Yeah, and either on treating with excess of HI and then on treating with the sodium in presence of tetrahydrofuran. What is the product you are getting here? Yes, it's a very simple question, just need to go through the mechanism only. Yeah. Okay, HI. What is going to happen? Here lone pair is there, here H plus and I minus is there, and this lone pair will be attacking on this H plus. What is the product we will be getting first? Yeah, we will be getting OH plus. Okay, now we all know that positive charge on oxygen is not stable, so there will be a shifting of bond towards oxygen which result in the formation of an OH here. Then yeah, then there will be negative charge will be coming on this carbon, and that negative charge will be held by iodine. Okay, now what is the next step? Here in the solution it is mentioned that there is excess of hydrogen iodide. Okay, now again this hydrogen will be attacking on the lone pair of oxygen and attacking on the lone pair of oxygen. What is going to happen? Which will result in the elimination of water. this lone pair of electron of oxygen will be attacking on H plus, which will be resulting in the elimination of water here, that is minus H2O. And when water is eliminating, this will be getting a negative charge. This carbon will be getting negative charge. No, not negative charge, will be getting a positive charge, and that positive charge is attacked by iodine. So finally, what is the product you are getting? Yeah, you will be getting iodine on both sides. Listen carefully. OH will be taking proton, and we will be getting water at this point, and the water will be eliminating. When water is eliminating, this carbon will be getting a positive charge, right? And as positive charge will be attacked by I minus, and you will be getting an alkyl iodide. Okay. Now this alkyl iodide, on treating with what? Sodium in presence of tetrahydrofuran. Sodium in presence of tetrahydrofuran. What is this? It is nothing but Wood's reaction. What is Wood's reaction? Elimination of this NaI and leading to the formation of alkane. Alkyl halide will be converting into alkane. That is, these two bonds will be combining together with the elimination of 2 NaI. Okay, that is what the complete reaction. Is it clear, everyone? Is the reaction, everything is clear? Shall I move to the next question? Yes. Yeah, the number of gram molecule of oxygen in 6.02 into 10 to the power 24 CO molecule is. Gram molecule and gram atom. This I have clearly mentioned in the mole concept chapter. Yeah. Have you got the answer? But this is little bit tricky. You need to just go through little bit inside of it. Then only you will get the correct answer. Yeah. Have you all got the correct answer for this question? Yes or no? Okay, we can solve it. Gram molecule of oxygen. What does it mean by gram molecule? Which means they are asking, or they are given with the number of moles of oxygen. As it is molecule, it is mentioned as gram molecule. If it is a atom, then instead of number of mole, they can mention gram atom. So gram molecule, it is nothing but mole. Number of moles, the number of moles of oxygen in 6.02 into 10 to the power 24 CO molecule is. That is what the question. Okay. Yes. So we all know that for 1 mole, or for 1 gram molecule, how many molecules will be there? 6.022 into 10 to the power 23 molecules will be there. Okay. Then for 1 molecule, how many gram molecule will be there, or how many mole will be there? 1 by 6.022 into 10 to the power 23. That is for 1 molecule. Now for how many molecule? For 6.02 into 10 to the power 24 molecule, how many gram molecule of CO will be there? 6.022 into 10 to the power 24 divided by 6.022 into 10 to the power 23. This many, yeah, which means 10 moles of CO, or 10 gram molecule of CO is present in 6.022 into 10 to the power 24 molecule of CO. 6.022 into 10 to the power 24 molecule of CO. Okay, now did I get the answer? No, we didn't get the answer, because the question is not asking about how many gram molecule of CO is present. The question is how many gram molecules of oxygen is present. How many gram molecule of oxygen is present? How we can solve that one? 10 mole of CO we got that 10 gram molecule is present in 6.022 into 10 to the power 24 molecule of CO, which means we know that 1 mole of CO or 1 gram molecule of CO is having 1 oxygen atom, right, which means 10 mole of CO have, or 10 gram molecule of CO, 10 gram molecule of CO has how many oxygen atoms? It is asking about oxygen atom, right? Okay, so 10 gram molecule of CO has 10 oxygen atoms, 10 oxygen atoms. 10 oxygen atom, or I can say 10 gram atom of oxygen. 10 gram molecule of CO has 10 gram atom of oxygen. Okay, now question is asking in terms of molecule. 10 gram molecule of CO has 10 gram atom of oxygen, because oxygen is an atom, so I have to represent it by using gram atom only. Okay, but we have to give the answer in terms of molecule, which means what I can do, instead of 10 gram, if I am taking 5 gram atom or 5 mole, okay, instead of that, if I am taking 5 gram molecule of O2 molecule is there in 10 mole of CO. In terms of molecule, I can say that. In terms of atom, I will be saying 10 gram atom of oxygen is there, but in terms of molecule, if I am writing it as O2 molecule, then it is 5 gram molecule or 5 mole of oxygen will be there. Okay, is it clear to everyone? In the last part, it is a little bit confusing, but just understand that the question is asking in terms of molecule, not in terms of atom. That's why I have converted 10 gram atom into 10 gram atom into molecule. When I am converting it into molecule, oxygen atom will be converted to oxygen molecule, and the 10 gram atom will be converted to 5 gram molecule. Got it? In total it will be 10 mole only. Is it clear, everyone? Okay, yeah, just go into the solution, we can understand this one. It's not a big question. Just that gram molecule, gram atom, that term only will be confusing you. Gram atom is a term that we are using for 1 mole if for a gaseous substance, and 1 gram molecule is a term that we are using for 1 mole if it is a molecule substance. Okay, now the next question. The boiling point of aldehyde and ketone lie in between alkane and alcohol of comparable masses, because between alkane and alcohol, we know that boiling point of aldehyde and ketones is actually higher. What is the reason? Alcohol will be having highest boiling point, then comes aldehyde or ketone, and the least one is for alkane. What is the reason? For alcohol it is having higher because of hydrogen bonding, alcohol is higher, and for aldehyde and ketone it is having a dipole interaction. Yes, dipole interaction. That's why it is having next highest. Alkane it is having weak van der Waals force. Yes, very good. So what is the answer? Alkanes are held together by weak van der Waals force, and being non-polar, aldehyde ketones contain polar carbonyl groups held together by strong dipole interaction, and lower alcohol have hydrogen bonding which is stronger than dipole. Yeah, option D is the correct one. Yes, I hope all of you got this correct one. Okay, shall I move to the next? Students, next question. Yeah, given the equilibrium constant for the reaction 2SO2 plus O2 gives 2SO3 has a value of 278 at a particular temperature. That is, here the reaction is given 2SO2 plus O2 gives 2SO3. What we have to find out? We have to find out the equilibrium constant for the following reaction. Here the equilibrium constant is given as, okay, given the equilibrium constant for the reaction has a value of 278. Okay, here the equilibrium constant for this reaction, it is representing as K1M. It is 278. What is the value of equilibrium constant for the following reaction at the same temperature? As there is no change in temperature, here the equilibrium constant value is also not going to change. Okay, but we have to find out equilibrium constant value for this particular reaction. SO3 gives SO2 plus half O2. How we can do this? Okay, let's suppose this is the new equilibrium constant for this one is K. What you have to do is rearrange the equation 1, rearrange the equation 1 in such a way that you will be getting this second equation. You will be getting the second equation. How we can rearrange it? Now look at here in the second reaction, SO3 is coming in the left hand side. So in the first equation, SO3 is in the right hand side. So what is the first thing that you should do is reverse equation 1. When I am reversing equation 1, the new equilibrium constant K, it will be 1 by K1. The new equilibrium constant will be 1 by K1. Now after reversing, what is the reaction? We are getting 2SO3 gives 2SO2 plus O2. Now after reversing also we didn't get the second equation. Then what do I have to do? Yeah, for getting the second equation, what is the next thing we have to do is divide the above equation by 2. If I am dividing the first equation or this equation by 2, what we can get? SO3 gives SO2 plus half O2. Now after doing these two rearrangement, I got our equation. So whenever I am dividing an equation, the new equilibrium constant K will be what? It will be coming as 1 by K1 whole to the power 1 by 2. That is, when I am dividing, that will goes to the power. If I am dividing, that will goes to the power. Okay, here I have divided it by, or if I have, here I have multiplied it with by 1 by 2. Whenever I am multiplying any equilibrium reaction with a number, that number will go to the power. So what is the total equilibrium constant? Total equilibrium or net equilibrium constant will be root of 1 by K1, which is equal to root of 1 by 278. What is the answer? Root of 1 by 278. It is coming around 16.7. This thing I will be discussing it in the chemical equilibrium chapter, which I will be taking tomorrow. Don't worry about this one. This is the characteristics of or properties of equilibrium constant. If I am reversing any reaction, then the equilibrium constant will become the reciprocal of it. If I am adding any two reaction, then the new equilibrium constant will be coming as the product of equilibrium constant of two added reaction. If I am multiplying any reaction, then the new equilibrium constant will be coming as the power of the old equilibrium constant. So all these things we will be discussing it in the next day class, that is chemical equilibrium. Okay, is it clear everyone? Shall I move to the next question? Students, if it is not clear, just tell me, I can explain it once again, or whichever the part that you are not clear, that you can let me know. Okay, Going to the next question. Threshold frequency is the maximum frequency required for the ejection of electron from the metal surface. Is it correct? Is it the maximum frequency? No. Yeah, it's not the maximum frequency. It is the minimum frequency. Minimum frequency required to eject the electron from a metal surface. And threshold frequency is characteristics of a metal. Is it correct? Yes, it is characteristics of a metal. Threshold frequency or threshold energy, both are characteristics of a metal, and it is different for different metal. If for sodium, if the threshold frequency is 70 joule, then for potassium it will be 80 joule or another value. It is a characteristics of a particular metal. So what is the answer? Yes, option D. If assertion is incorrect, assertion is incorrect and reason is correct. Yes. Next question. Coordination number and oxidation state of chromium in K3Cr(C2O4) 3. What is the answer? What's the answer for this question? Students, let me know. What is the answer for this question? Yes, we know that C2O4 oxide, it is a bidentate ligand. C2O4 bidentate ligand. As it is bidentate ligand, the coordination number is equal to how many C2O4 is there? 3 C2O4 is there into its density, that is 2. It is equal to 6. So only option we can see it is B. And if you check the charge, yeah, you can find it is coming as +3. Okay, I hope it is clear. It's an easy question from the coordination compound chapter. You can find it by yourself itself. I am moving to the next question. Yes, what is the approximate pH of a 10 to the power minus 3 molar NaOH solution? What is this? What is the question? pH calculation. pH is equal to minus log H plus, or pOH is equal to minus log OH minus, and pH plus pOH, what it is? It is equal to 14. Using this we can find out the answer. Here it is NaOH. As NaOH is a strong electrolyte, OH minus. As it is a strong electrolyte, at time t equal to 0, if the concentration of NaOH is 10 to the power minus 3, this is 0, this is 0. At the end of the reaction, or T 100%, this will be 0 and this will be 10 to the power minus 3, this will be 10 to the power minus 3, which means I got the OH minus ion concentration, which is equal to 10 to the power minus 3. If you got OH minus ion concentration minus pOH, it is equal to minus log OH, which is equal to minus log 10 to the power minus 3. 10 to the power minus 3, in which the answer is coming as 3. pOH we got the answer as 3. But what about pH? pH is equal to 14 minus pOH, which is equal to 14 minus 3, which is equal to 11. This is the correct one. Option B is the correct one. Is it clear, everyone? This we will be discussing it in the next class. Don't worry about it. pH, pOH calculation. If it is clear, I can move to the next question. Guys, are you ready? Yes, just a pOH calculation only. Yes, water is a better proton donor than alcohol. Is it correct? Water can be a better proton donor than alcohol. Alcohol is a weaker acid than water. Is it correct? What is the answer? Option A, B, C, D. What is the answer? Yes.
Option C.
Option C. Assertion is correct, but reason is incorrect. Is it? Okay, we can see
Option B.
Option, but reason is not the correct explanation. Okay, we can see it. ROH, alcohol, and H2O, water. How we can decide which one is a good acid, whether the conjugate base is stable or not? Here, on doing this, what I will be getting? I will be getting the conjugate base RO minus plus H plus, and here water on doing what I will be getting the conjugate base OH minus plus H plus, right. Now among these, which conjugate base is more stable? Which conjugate base is more stable? Here we can see due to the presence of an electron donating group. Electron donating group will increases the magnitude of negative charge on this oxygen, which means this conjugate base is less stable. As it is less stable, it is less acidic. Here oxygen is there on the, oxygen is having negative charge. Negative charge is present on oxygen. Negative charge will be more stable if it is present on more electronegative atom. So it is, this conjugate base is more stable and it is more acidic. So I can say water is more acidic than alcohol, which means alcohol is a weaker acid than water. It is correct. Okay, what is the reason? Yeah, water is a better proton donor. Water is a better proton donor than alcohol. Yeah, water is a better proton donor than alcohol. That is the reason why alcohol is a weaker acid than water. Okay, both are just given as reason and assertion in a different way. So we can say both assertion and reason are correct, and reason is also the correct explanation. Okay, water is a better proton donor because water is a good acid than alcohol. Water is a better proton donor because water is a good acid than alcohol. So both are correct, and both is the correct explanation also. Okay, shall I move to the next question? Is it clear, everyone? Okay. Statement 1, 2 and 3. Hydrogen bonding donors and hydrogen bonding acceptors. First of all, you should know what is hydrogen bonding donors and hydrogen bonding acceptor. What is hydrogen bonding donor and what is hydrogen bonding acceptor? Okay, for hydrogen bonding donor, I will give you the definition. Hydrogen bonding donors. For hydrogen bonding donors, there should be a hydrogen atom. There should be a hydrogen atom attached to an electronegative atoms like oxygen, nitrogen or fluorine. That is what hydrogen bonding donors. What is hydrogen bonding acceptors? Bonding acceptors. Hydrogen bonding atom. For hydrogen bonding atom, there should be a lone pair of electrons. There should be a lone pair of electrons present in the electronegative atom. This is a condition for a compound to be a hydrogen bonding donor and hydrogen bonding acceptor. Okay, now if you see hydrogen bonding donors, and here it is asking about primary, secondary and tertiary amine. Okay, primary, secondary and tertiary amine, what is the condition? There should be a hydrogen atom attached to an electronegative atom. For primary and secondary we know that they are having hydrogen atom attached to a electronegative atom, that is nitrogen. So they are hydrogen bonding donors. But for tertiary they are not hydrogen bonding donors. Tertiary it is not a hydrogen bonding donor. Okay. Now for hydrogen bonding acceptor. Hydrogen bonding acceptor, what is the condition? There should be a hydrogen atom. There should be a lone pair of electron present on the electronegative atom. There should be only lone pair of electron present on the electronegative atom. If I am comparing primary, secondary and tertiary, primary, secondary and tertiary, all these are having a lone pair of electron present on the nitrogen atom. So they all are hydrogen bonding acceptor. Hydrogen bonding acceptor. So what is the correct one? Is the statement 1 is correct? Primary, secondary, tertiary amines are hydrogen bonding donor. Primary, secondary and tertiary, are they hydrogen bonding donors? No, primary and secondary are hydrogen bonding donors. As tertiary don't have the hydrogen atom, we know that tertiary have only nitrogen atom attached with the 3-methyl group. So this statement is wrong. Now what about second statement? Low molecular weight amines are soluble in water. Is it correct? Second statement, low molecular weight. Is it correct? Yes, that is correct. Why? It is correct because of the less number of hydrophobic alkyl group. Less number of hydrophobic alkyl group increases the solubility. Low molecular weight amines will be having lesser number of alkyl group. Alkyl groups are hydrophobic in nature, which will decreases the solubility. So less molecular weight will be more soluble in water. Are soluble in water. So statement 1 is incorrect and second one is correct. 1 is incorrect and second one is correct. Okay, shall I move to everyone? Shall I move to the next slide? Yes. Okay, for this reaction, for the reaction 2A plus B, the product, this is the product that is for giving a product. When the concentration of A and B both were doubled, the rate of the reaction increased from 0.3 to 2.4. When the concentration of A alone is doubled, the rate increased from 0.3 to 0.6. Okay, which one of the following is correct? We have to find out the order of the reaction, that's the only thing. According to the rate equation, R is equal to K into concentration of A raised to the power X, concentration of B raised to the power Y. We have to find out X and Y, that's the only thing. For that we can take out the details. According to the first data given in the question, when the concentration of A and B were doubled, that is A become 2A, B become 2B. What is happening? The rate of the reaction increased from 0.3 to 2.4, which means the rate will be 2.4. Okay, now we can take a equation in which 0.3 is the rate. 0.3 is equal to K into A to the power X, B to the power Y. This is the first equation, this is second equation. That is, rate has increased from 0.3 to 2.4 when it was doubled. Now we can go to the second statement given in the question. When the concentration of A alone is doubled, the rate increased from 0.3 to 0.6. A alone is doubled, so 0.6. K into A, only A is only doubling, that is A will become 2A and B will become Y. Third equation. Now on rearranging the first, second and third equation, you can able to find out the value of X and Y. How we can do that? Okay, I am just comparing equation 1 and 3. On comparing equation 1 and 3, what I am doing is divide equation 3 by 1. On dividing equation 3 by 1, you can see 0.6 divided by 0.3, which will be equal to K into, okay, not equation 3 by 3 by 1 also we can do, K into 2A to the power X, B to the power Y divided by K into 2A to the power K into A to the power X, B to the power Y. Okay, from this we can cancel out these things. So on cancelling these things, what we are getting? 6 by 3 we will be getting 2. 2 is equal to 2A divided by A, it is A to the power X, and 2 to the power 1, which means X is equal to 1. I got the value of X. An easy one. Now how to get the value of Y? What you can do is, you can compare the equation 2 and 3. that is equation 2 divided by 3, equation 2 divided by 3, that is 2.4 divided by 6, which is equal to k into 2a whole to the power x 2b whole to the power y divided by k into 2a whole to the power x b whole to the power y. Now from this we can able to find out that 4 is equal to, on solving this, 4 is equal to b to the power y. 4 I will be writing it as 2 to the power 2, and which means b to the power b to the power b to the power 2, which means y is equal to 2. So I got the value of x is equal to 1 and y is equal to 2. So what is the correct answer for this question? What is the correct answer, students? Yes, order of the reaction with respect to A is 2, with respect to A is 1, with respect to B is 1, order of the reaction with respect to B is 1. That is the correct one. Okay, yeah, now shall we move to the next question? Okay students, I think the time is up. Do you have any particular question to be solved that I can do it now? We already have reached 1:30, but if you have any particular question to be solved, that I can solve it now. Anything if you have like that I can solve it now. This question, bond order question, that is easy only, you can do it by yourself, that I have discussed in the chemical bonding chapter. Then neutral and this thing I have mentioned it in the last class. I have mentioned this one in the last class, last PYQ discussion, not PYQ, a paper discussion time. That is thiosulfate S2O4 will be converting into SO4 2- in the case of neutral or faintly alkaline solution. Okay, now the next question you just see. Oxidation number calculation. Oxidation number calculation is also, you can do it by yourself. Then this one, molar conductance. Molar conductance, the equation, just you have to just note down the equation. Lambda m is equal to 1000 into k by m, in which k you can calculate by L by A into 1 by R. Everything is given in the question. From that you can find out the lambda m value. Okay, then yeah, the same type of question only we have did it few minutes before, like just take the ratio of it and get the order, calculation of order. The same type of question we have did it. Yes, now carboxylic acid can best be converted into acid by using the same question we did in the beginning, that is by using SOCl2, because we are getting gaseous product here, This also we can use, but here more number of gaseous products are forming, more number of product is also not advisable. Okay, now this one, this is also direct question only, that is electrophilic aromatic substitution, you can do it. Yes, now the compound formed in borax B test of Cu2 plus ion. Okay, just I will be giving an idea about this question, just note it down, because borax B test has been repeatedly asked in the exams. What is borax B test is, it is used for finding out the metal ion, it is used to find out the metal ion based on the color it is forming when I am heating it. So how we can understand that one is, first of all, borax on heating, borax is Na2B4O7. Borax on heating, what I will be getting, borax, I will be getting a glass like borax bead, and this glass like borax bead on treating with metal salt, what I will be getting, metal metaborate, and the formula of it is MbO2N, where N is the oxidation state of the metal. This is enough, just take a screenshot of it. This is enough to solve a question related to the borax bead. Now I can take, this is my ion, that is Cu2 plus ion. It will be giving what compound? What is the metal? Metal is CuBO2. And what is the value of N? N is the oxidation state of this metal, that is 2. So the answer is coming CuBO2 twice. Okay, this is borax B test. I have seen this in many of the mock tests. So take a screenshot. Using this you can solve most of the things. That is MbO2N. and N will be the oxide state of the metal what we are taking here. Okay, now the remaining questions. Yeah, enthalpy things and all. One point you have note down is, for according to the new IUPAC or international convention, what is happening is they have removed one ATM. For standard condition they have removed one ATM and they have made it as 1 bar. According to the new international IUPAC law, 1 ATM standard condition they have removed 1 ATM to 1 bar. So if you see 1 ATM, that is a wrong one, 1 bar is a correct one. Okay. Now next question, isomers, number of isomers possible, that is 3, because here it is only linkage isomer is only possible. Only linkage isomer is only possible, and 3 linkage isomers you can see here because there are two NO2 molecules there. Remaining question, yeah, that is same question only. Yeah, this also same equilibrium constant question only. This I will solve in the next class. Next class means tomorrow's class. Equilibrium I will be taking in the tomorrow's class, that I can solve it here. Okay, this is completely based on the Henry's constant, that is pressure of a gas is equal to Henry's constant into mole fraction. Higher the pressure, higher will be the Henry's law, Henry's constant. Yes. Now 87 also like direct question only. Benzene sulfonyl chloride, it is Hinsenberg reagent. Hinsenberg reagent is used to differentiate primary, secondary and tertiary amine. Then benzene diazonium fluoroborate, that is water insoluble. Most of the benzene diazonium chloride are water soluble and they are very less stable. But benzene diazonium fluoroborate, they are stable and they are water insoluble. Then alkyl diazonium salt, they are used for conversion to alcohol, and aryl diazonium salt, they are used for coupling. By coupling they will be used for dyes. Then this one, yeah, SN1 and SN2 inversion and retention configuration, that you can refer the NCR textbook, it's direct question only. Yes, last question is about the ozonolysis. Refer my first mock test discussion. In that I have mentioned how we can find out the product. Here the product that is formed are CHO, that is C double bond O. And what is another product that is formed here? CH3CO, CH2, CH2CO. C double bond O, C double bond O, CH2, CH2, C double bond O, CH3 and CH3. How you can find out the product? What I said, remove the oxygen and then combine this carbon with the double bond. That's the only thing you should do here. Double bond C double bond, and this carbon is attaching with this carbon, then CH2 combining. Now this carbon is having a CH3 group, CH3, and that carbon is having another CH3 group. What is the answer? You can see the answer C is coming. Ozonolysis reaction is very easy, you can easily find out the product. Okay, so we have solved all the questions. Still, if you have any doubt in this, you can let me know or reach out to me in WhatsApp or in any other way. Okay, or you can just tell me in the next class. So students, that is all about today's class. Do well in the tomorrow's class. That tomorrow I will be taking chemical equilibrium and ionic equilibrium chapter. Just revise that chapter once by today, so that tomorrow it will be easy. So thank you all. Yeah, thanks for joining.